Hello everyone, this is Teacher Justina and welcome back to my channel. If you are still new, do not forget to subscribe, like, and share for more videos. Our lesson for today's video is all about derivatives of exponential functions. So let us have its formula in finding the derivative of exponential function. So you are given d over dx of e to the u is equal to e to the u times the u prime. So e to the u refers to the function itself times the u prime. When we say u prime, it's the derivative of the exponent. So u refers to the exponent of e, then you have to multiply it to the derivative of the exponent. So let us have number 1. So you have there y equals e to the 5x. So according to the formula, we just simply copy what is e to the u, and then the derivative of our exponent, which is 5, will be here. Thus, our final derivative is y prime is equal to 5, then e to the power of 5x. So what about number 2? So again, we just simply copy e to the power of 2x minus 4 times the derivative of 2x is 2. Thus, we have a 2 there. So, its final answer will be 2e to the power of 2x minus 4. So, this is already our final derivative. Let us have number 3. So e to the power of x to the 4. So far, we just simply copy e to the power of x to the 4 times the x to the 4 is considered a function. Then what is its derivative? So that will be f prime of x. So the 4 will be multiplied to an imaginary 1. There's a 4. And then the 4 will be always subtracted by, so our exponent, according to the power rule, we still have to apply the power rule. So 4 minus 1 will be 3. So therefore, e to the x to the 4 will be multiplied to 4x to the power of 3. So its final answer is 4x cubed e to the power of x to the 4. Okay, let us have number 4. So again, we rewrite e to the negative 4x plus 2. And remember that our u there is negative 4x plus 2. And what is its u prime? So of course, this will be negative 4. So this will be multiplied to negative 4. And our final derivative is e it's we have to write first the coefficient. So we have the negative 4 and then e to the negative 4x plus 2. Okay, let's proceed to the next. Let us have number 4. So e to the power of 10x minus 4. So we have e to the 10x minus 4. And so far, 10x, its derivative is 10. So our final derivative is 10e to the power of 10x minus 4. Well, number 5, we have e to the power of 2x to the 4 times. So our u there is 2x to the power of 4. And then its derivative will be 8x to the power, you have to subtract 1 to 4, so that will be 3. Okay, so therefore it will be multiplied 8x cubed to the e to the 2x to the 4. So I hope you get it. So 8x cubed e to the power of 2x to the 4. Okay, then let's proceed to the next example. So e to the power of x to the 5th minus 7x. So again, we just simply copy e to the power of x to the fifth minus 7x times the x to the fifth minus 7x. So that will be our u. That is our u. So our u is x to the fifth minus 7x. And since we will be multiplying this entire function to the derivative of our u, so our u prime is the 5 will be multiplied to the imaginary 1 there. So that will become 5x. And the 5 minus 1 will be 4. And the negative 7x will give you a negative 7. So therefore, we will have now the derivative of our u is 5x to the power of 4 minus 7. Okay, so to finalize our answer, well, anyway, this is already composed of two terms. Thus, we can write this ahead of the exponential function, 5x to the 4 minus 7 times e to the power of x to the fifth minus 7x. Okay, so therefore, we could consider this as our final answer. Okay, let's proceed to number 7. So as you have seen, number 7 is already composed of two factors. So in this case, we have to recall the derivative of the product of two functions. So far, the product of two functions is being denoted by the formula. The product of the two functions is equal to the first function times the derivative of the second plus the second function times the derivative of the first. So therefore, let us now do the indicated notation in getting the derivative of this. So our f of x, considering this is our f of x, and considering this one, this will be our g of x. So according to the formula, it says copy the first function as is. So we will copy e to the power of x times the derivative of the second. So the derivative of x squared plus 1 is 2x. Then plus the g of x refers to the second function. So our second function is x squared plus 1 times the derivative of our first. Remember, this is an exponential function, e to the x. So what is its derivative? So we have to copy e to the x times, what is our u in the e to the x? It's x. So what is its derivative? It's 1. So therefore, to further simplify, we know that e to the x times 2x plus x squared plus 1, simplifying e to the x times 1 is e to the x. Okay, now I just want you to observe that each term, okay, this is our first term and this is our second term. And so far as you have seen, each term has a common e to the x and there is an e to the x in there. So we can have e to the x as our common monomial factor. So if this is the case, this e to the x times 2x divided by e to the x. So therefore this will become 2x. Okay. And then a plus the x squared plus 1 times e to the x. The e to the x there will be equal to 1 if we will be dividing this expression by our common monomial factor e to the x. So what is left there is x squared plus 1. Okay, so can we consider this as our final answer? Well, anyway, we can still adjust the terms inside the parentheses by, okay, I know that you have known it already, that in writing a polynomial, we have to write it in a decreasing order. So that will be according to their degree. So x squared followed by 2x plus 1. Okay, so could this be our final answer? Okay, this could be our final answer, but still, if you are still to recall your previous knowledge, this could still be simplified into uh, this could be simplified into a to the power of x. You know that x squared plus 2x plus 1 is a perfect square trinomial in which its factors are x plus 1 times x plus 1. So therefore, we can write it in this way. So therefore, this is our final derivative in number 7. Okay, so that will be if our base is e, if it is an exponential function. What will happen if our base is no longer e? It's other than e and it's a constant. So let us try this. So you are given d over dx is equal to, not equal to, but d over dx of 7 to the 2x minus 5. So how do we get its derivative? So since our base is no longer e, so we can no longer use what was it? It is e to the u times the u prime, but instead we will be using this notation already, where a, okay, where a should not be equal to 0. Okay, so therefore a is a constant, any constant. So what will happen if we will be getting its derivative? So simply, whatever the given function, we just simply rewrite it. So 7 to the power of 2x minus 5, and then you have there the u prime. When we say the u prime, what is our derivative of its exponent? So again, this is our u, and the 7 is our a. So therefore, so we have written the entire 7 to the 2x minus 5 times what? Times the derivative of 2x minus 5, which is 2. Okay? So, and then times the natural logarithm of the constant a. So our constant there is 7. Okay, so therefore, can we multiply them? Okay, no, we can consider this as our final answer. We cannot multiply the 2 and the 7 because 7 is a natural logarithm and the 2 is a constant. We cannot multiply it to the 7 because a 7 has a 2x minus 5. So we can consider this as our final. So let us proceed to number 2. So number 2, you have there 9x to the power of 5. So we simply copy 9 to the power of x to the 5 plus 3 times x to the 5 plus 3. Okay, so considering that our u is x to the power of 5 plus 3, and what is its u prime? So our u prime is 5x to the power of 4, and a constant will be its derivative is 0. So therefore this will be 5x to the power of 4 ln of 9. Okay, so this is our derivative in number 2. While number 3, we have there 5 to the power of 2x minus x squared times the derivative of our u. Remember, our u is 2x minus x squared, and our u prime is this, the derivative of 2x is 2 minus the derivative of x squared is 2x, And 2 minus 1, it's already a 1. So this is our u prime. So our u prime, as we have in the formula, so we have to multiply 2 minus 2x times the ln of 5. Okay. Guys, I hope these examples help you understood the derivative of an exponential function in which having a base of e and at the same time what will be its notation if our base is no longer e but a constant. Uh, I hope you will still follow me on my YouTube channel, and do not forget to subscribe for more video updates. This has been Teacher Justina, and asking you to keep on following me on my channel so that you could be updated always. Thank you everyone, and thank you for watching.